Hi class. This tutorial video covers some common errors that you might encounter when running your first script. I have errors that I have intentionally worked into the code and into the data file, so that way we can take a look together at what the error message produces and how to resolve it. This is for the Biology 229 data analysis module. And my name is Dr. Pyle, and I'm the course coordinator for Biology 229. We'll get started in R. This video is assuming that you've already set your working directory and installed RStudio, and you have installed the ggplot2 library. If you haven't done those things, please go back and watch the previous video on how to run the t-test analysis in R. Okay, so we'll get started by running through this file. And again, I'm going to skip the first few lines that are commented out. And the first thing I'm going to do is run my library line of code to get that ggplot2 started. The next thing that I'll do is run line number 11 to set my working directory. So I'm going to run this line of code instead of, in the previous video, I suggested using this gear icon. Instead of doing that, this time I'm going to run this line number 11. You can see that we see an error message. The error message is displayed down here in the console, and it says error in that line of code, could not find function setWD setWD. Okay, so the problem is that I have a typo in my function name, and it looks like I've copied that function name twice. So setWD is not a valid function name. So I need to correct that, and I'll do so up in the editing pane just by deleting one of those copies. Now I have a valid function name, setWD. I can double check to make sure that I'm working with a valid function name by down in the console, you can type a question mark and then that function name. If you hit enter and it's a valid function, you'll get some information about it. So this is how we get help on different functions by typing question mark. Over here, it opens up the help pane and it gives us some information about that function setWD. If instead I have a setWD twice, like I did before, then we'll see what happens with that question mark function. And again, this is down in the console, not in my editing script window. So for this one, it's not a valid function. That's why it says no documentation for that function name. Okay, that's my clue that I need to go back and check to make sure there's no typos in my function name. Okay, so now we have this setWD. It's a valid function. I'm going to use command return. It's still not working, however. This time we see the error, cannot change working directory. That means that I have an error in my working directory file path. So I need to double check that file path. I am working within documents, and my folder is called 1UTK. My next folder is Biology 229 data. Oh, here I'm able to see that I'm missing part of my folder name. This folder is actually called data analysis. So I need to make sure that I include the accurate folder name within this line. I'll try to run it again. Okay, this time it worked. I know because I have blue text down here in the console and there are no error messages. So we're ready to move on to the next step. Now I'm going to do step number 2. I'm going to name my object antibiotic zones with my by reading in or importing that CSV file that I created in Excel. So I'll run this line of code and it does import, and I do have an object, antibiotic zones. The next thing that I'll do is run the structure of that object. Okay, now it's time to inspect the structure of this object. And I see that I have a data frame, which is another way of naming that spreadsheet, that CSV file. It says that I have 12 observations, meaning there were 12 measurements made on two different variables. The variables are my columns. I do have two columns, but I'm already thinking that there might be something fishy going on because I know that my class took 10 measurements, not 12. So this 12 observations has already got me suspecting that there might be something wrong here. I look at the column names and I see I have a column named BIOL229.Jane Smith. I have another column name that's just called X. That doesn't sound right to me, though I don't recall those being my two column names for this data set. So I'm going to open up this object in R, antibiotic.zones, and inspect it. And now I can see what the problem was. I see that my bacterial species and my zone diameter are actually appearing in row number 2 when they should be my column names instead. Up here I've got this name, BIOL229, Jane Smith, and X here. And it looks like R has imported those two as my column names, but that's not right. So I need to go back into Excel and make some modifications. In an upper level programming class here at UT, you can learn how to modify this within R. But for this exercise in 229, we're going to go back into the Excel file and make the modifications directly on the CSV file. So I will open up that file within Excel. And I can see why R imported those two column headings because it's always going to import whatever's in row 1 as the column heading into the CSV because of the way that we've got the default parameters set. So column 1, when this student saved this data file, they put the class name and their name within row 1 in column A. And that's going to create problems with the way that R imports this data file. So we don't want to have anything in row 1 or 2 that's not related directly to the data that we want to analyze. So I'm going to just delete those 2 rows. There's also that empty row number 2, which was imported as an empty row into R as well. So I'll delete those 2. Now I have bacterial species and zone diameter, and both of them are in row 1. So I'm going to make sure that I save this file. And after I save it, I'll come back to R, back to my code file, and now I need to recreate that object by reading my CSV. So I'll go back to line 14 and hit Command Enter. Okay, now I've read in my new object. I can tell that it's updated because now I have 10 observations, which sounds right. I know that I made 10 measurements. I can go down to line 18 and inspect the structure of that object by hitting Command Enter. So we're looking at a data frame. We have 10 observations, 2 variables. That all looks right. I have my first column is called bacterial species. It is a character variable type, meaning it has letters and punctuation and space. I've got a few examples of E. coli provided here from the first few rows of data. My next column is called zone diameter, and it's also character type. Now this will be a problem because we can't do data analysis on character variables. We need to make sure that it's either an integer or a number. And I can see what the problem probably is right away based on this preview. I see 11 space MM, 13 space MM. So when this person entered data into the file, they included spaces and letters next to the measured number. That's why R imported it as a character type. If there's any spaces or letters, it will be imported as character type. So again, I'm going to reopen the file in Excel and make some changes. And I can see here my first few rows do have that space MM. So I can just easily delete that. I want to make sure that I delete the letters as well as the space, because if there's any space remaining, it will be interpreted as a character by R. Okay, so I've cleaned that up. Now all of my numbers do look like numbers. I'm going to save this file again. And when I come back into R, I need to reopen that file and recreate the object. So I have to go back to line 14 and run that line again. Okay, now let's try inspecting the structure again. Okay, so now I'm looking down in the console. I have a data frame, 10 observations of 2 variables. In my first column called bacterial species, those are all character values with E. coli is my preview. Then my next column is called zone diameter, and now it's imported as integer type, and I have these whole numbers. If you have any decimal numbers, then it would import as numeric or NUM, and that's fine too. Integer or numeric will both be able to be analyzed by the t-test later. Okay, this looks good. We're ready to move to the next step. So now we want to double check the levels of each categorical factor. Remember, we're running a t-test and there should be 2 categorical factors that we're making a comparison between. So I'm going to go to line number 21 and run this line of code. Okay, I see a problem right away. I know that I should have 2 levels because I have 2 bacteria that I measured, but it looks like I have more than 2 levels in this data frame. I have 1, 2 different examples of E. coli, and then there's 5 different levels for Staphylococcus aureus. And I can see right away that each of these Staphylococcus aureus levels, they have a number at the end. So when this person entered data into the CSV file, they must have entered a unique number for each Staphylococcus aureus species that they measured. We will have to go back into the Excel file and delete those numbers. There's also something happening with E. coli, and I see that there's no numbers associated with E. coli, but there's something else that's making it different and causing R to interpret there being more than 1 level of that category for E. coli. Let's start by deleting those numbers for staph because that's an obvious issue. I'm going to go into each one of those and delete it. I also want to make sure that there's no typos in that species name. If somebody misspelled aureus, then it would be interpreted as 2 different categories or 2 different levels in R. Okay, now I know that I need to take a closer look at E. coli. Right now, it looks like all of the E. colis are the same. I don't really see an obvious difference between them. So I need to go back into R and just take a closer look. And I notice when I look at these different levels in R, the first one within the quotes is E dot space COLI, quote. The next one is E dot space COLI, and then I notice there's a space after that I. That space is causing R to interpret those 2 entries as being part of different groups. But I know for my experiment that all of the E. coli should be part of the same group. So I need to go back into Excel and just make sure that all of these are the same. Because I can't see spaces readily in Excel, I'll need to inspect each one of these cells. You might be able to see the spaces if you, for example, use the paragraph function, or if you open this file using another app like Notepad++, for example, which shows all of the computer readable characters. Within this first row, as soon as I place my cursor, I'm able to see that there is, in fact, a space at the end of this word. So I need to delete that space. And then I'm just going to check that all of the others, when I put my cursor at the end of that line, that there's no hanging space at the end of that line. Okay, I think all of my E. coli are typed exactly the same now, and all of my Staph aureus are also typed exactly the same. I'm going to save this file and reopen it. So line 14, I will rerun that line and come down to double check my structure. Again, structure looks great. I have a character column and an integer column. And now I'm going to run these levels, and now it looks great. I have one level for E. coli and a second level for Staph aureus. The next thing that I can do is run my t-test, and it runs correctly. There's no errors that are thrown. You might have gotten an error if, for example, you left off one of these periods within the column name, or if you spelled the column name differently than how it actually appears within that object that we created. So just make sure that you go back and look at that object and spell and use capitalization and have the periods in exactly the same spot as they appear in that object. Okay, the next thing that I'll do is come down to my graph file. Okay, and right away I notice there's a red X hanging out over here. And the clue that RStudio is giving me is that there's an unexpected token called species. It's not quite sure what to do with that. We'll run this line and see if we can solve that problem. So I'm going to run this line to create t-test graph. Okay, right away I notice that it only ran that top line. I can see down here in the console, I only have the top line that ran. It didn't run the whole chunk of code needed to make that graph. That's because I'm missing a plus sign here at the end of this line. So I'm going to make sure that I have a plus sign. And I'll try it again. So I go back to line 28, place my cursor anywhere in that line, and hit Command Return. Okay, now we have an error function. We have an unexpected symbol within this line. The problem here is that we forgot to have quotes around that axis label text. So remember that our axis labels are text, and they have to be quoted within that xlab function. There are other functions available for naming axis labels that don't require quotes, but this xlab function requires the text inside to have quotes around it. Okay, so now we can run this line, and we have one more issue within this code for making the graph. It says error in Y label. Could not find function Y label. That means I've mislabeled my function name. So the function is xlab or ylab. If I type the whole name label, that's not a valid function name. So I need to make sure I'm using a valid function name, in this case, xlab or ylab. Now I'll try to run line 28 again. And this time there's no error messages. I'm going to take a look at line 36 at that object that I've created by running that line. And now I have one more issue. It says there was a problem setting up the geometry aesthetics, an error within that geom box plot function. So we're looking at line 28 here. This is our geom box plot function. It's caused by this error where there's a function running in the background where it's checking the number of aesthetics and making sure everything lines up. It says the aesthetics must be either length 1 or the same as the data, in this case 2, because we have 2 categories, 2 levels to our bacterial species, E. coli and Staph aureus. So our aesthetics have to be either there's only 1 color, or it has to be the exact number as the levels within our data set. So we need to fix this. The problem is that we have 3 different colors here. We need to delete that last color because we only have 3. We have 3 colors listed, but there's only 2 boxes that need to be plotted. So I'll go back and delete that color and try to run this line again. Okay, that ran correctly without error. I'm going to create this graph, and now I have a functional graph. And everything within this looks exactly like it should. I can now save this file and copy it, paste it, or insert it into the worksheet and submit that along with the rest of my assignment. If there are any other issues that you might have encountered in your R script, you can ask your laboratory GTA for some assistance. This video covers a lot of the commonly encountered issues that we do see oftentimes with people who are using RStudio or writing in R programming language for the first time.